If you wanted to look at this extra example of a sine graph and with a scale that's a little bit different than having things that are looking like the familiar angles we saw, I was going to finish this problem for you guys. So we were looking at this problem, sorry about that, where our b value is pi over 6. And we already said that meant there was a horizontal stretch because 6 over pi was just a little bit less than 2, but definitely more than 1. The 2 in front for the a value definitely means there's a vertical stretch. And the plus 1 means that there's a shift up 1. And I'll come back to the chart since we already did the x coordinates and do that again. We talked about the period. For the amplitude, again, the amplitude is normally 1. However, there's a vertical stretch of 2, so the amplitude here would be 2. So before I get to the graph, this is still a sine function. So I do expect this sequence of points to follow the normal sine pattern. And normally, I'm looking at that being these marks and the fourth mark being 2 pi. So again, I'm going to draw it differently if there's a reflection, so I know to follow a different pattern. However, there was no reflection in either of these, so no reflection. I want to know if the midline is still at 0. So when I look back here, there was a shift up 1. So what that tells me is that the midline is going to be here around 1. I want to see the amplitude then to know how high and how low my graph is going to go. The amplitude, because of the vertical stretch, is 2. So I would expect my high points to reach 2 above 1 and my low points to reach 2 below 1. And then I want to know if I'm starting, so there's no reflection, it's not different. So like, am I starting here at 0 on them, but just on my new midline and going through this pattern, or is something else switching? So I want to look for a shift to see if that's where I start, but there's no shift left or right. So I'm going to start at 0, but I'm going to start on my midline. So I'm doing this point, and then I should go to a max and then down, back. Oh, my only bummer is I haven't scaled the x-axis yet. So remember here the period was 2 pi. We wanted that fourth mark out to be 2 pi. Here, if we want to get through one period, through like 5 marks, counting this 0 at the beginning, our period turned out to be 12. So we want this to be 12. We want to break that up into fourths since it's the fourth mark, and that means we're scaling by 3s. So even though it's a little odd not to see the angles you're usually used to seeing, these are in like whole number radians, it does make it a little easier to count. So we'd be looking at this, and then we're going to go through and we're going to graph. So the next point would be at the max, then back to the midline, then the minimum, then back to the midline. And so this is one cycle of that sine function. And then again, you should be able to then continue that pattern: max, midline, minimum, midline, and go back through it, or the other direction: minimum, midline, maximum, midline, and see that pattern continue. If you did the points, we had already done the horizontal change. The vertical changes were the stretch and the shift up 1. And remember, the sine parent function goes through these patterns. So we would see these values, and those are the same points that you see that we got on the graph. And then for domain and range here, again, the domain would be all reals, or in interval notation, negative infinity to infinity. And the range is going from a minimum of -1 to a maximum of 3. So whether you like the inequality notation or the interval notation. And so hopefully that gives you that extra example if you wanted to see that scaling, or you just wanted one more example of these types of problems.